Exercise A09 is concerned with squirrels living in Palo Alto, and we are going to write a computer program which is going to be able to determine, given the temperature and given whether it is summer or winter, if the squirrels are playing right now or not. So this might sound like unrealistic, and it is. However, the logical structure of this code is really close to what you are expected to produce when you are done with this course. So it is a very interesting exercise in that regard. The idea is that you can take with this exercise an English statement of a given problem, and you can analyze it for its logical structure and convert its logical structure into a computer program which will answer a specific question. So you have to see it like from this perspective. It's not an exercise that I offered. It comes from the javabat.com website, which we're going to use extensively in the second part of this course to actually give you some practice with the basics of Java programming. So let's have a look at our problem. Squirrels in Palo Alto spend most of the day playing. In particular, they play if the temperature is between 60 and 90, inclusive, unless it is summer. Then the upper limit is 100 instead of 90. So we have a very a logical puzzle here, a very simple program, and I'm going to clear my board here. We have a very simple problem statement that says, well, if it is summer or winter, then the squirrels are going to play depending on the temperature. When it is summer, the temperature has to belong to a certain interval. Okay, let me go back to the specification of our problem. When it is summer, we are talking about a temperature of 60 to 100 inclusive. When it is winter, 60 to 90. So let me codify this. When it is summer, we're talking about 60 to 100. When it is winter, we're talking about 60 to 90 degrees. So here's our problem. Our program will display on the screen the squirrels are playing, or whatever message we deem appropriate, whenever it is summer and the temperature is in that range, or whenever it is winter and the temperature is within this range. There are many different ways you can go about writing this program. Okay, I encourage you to try many different possibilities, many different solutions. I'm just going to give you one solution. It's not better, it's not maybe the shortest, etc., but it's just going to get you started and offer you an opportunity to correct your own mistake if you did some. What we want to write is a flowchart for Raptor, which is going to ask the user to provide both the temperature and summer. Temperature is going to be between 0 and 130, and the summer variable will contain a 0 or 1, depending whether it is summer or it is not summer. So right now, let's start by clarifying something. Okay, the problem description, as many problem descriptions often do, is not telling you what 0 stands for and what 1 stands for. Let's assume that 1 in the variable summer means it is summer, and 0 means it is winter. Okay, so this is what you do when you have like exercises that do not give you all the information. You document the assumption that you are making. If I was to write this code for someone, I would state in a comment in my program, or I would like contact them by email and tell them, when you read my program, keep in mind that I assume that when you type 1, you mean it's summer. When you type 0, you mean it's winter. Okay, so this is our problem statement. Let's see if we have anything else. Depending on the value that were passed to you by the user, you will determine whether the squirrels are playing or not and display on the screen an appropriate string. Okay, let's open a Raptor window. We have a little bit of work to do to prepare the ground. 2 input statements. One of them is going to prompt the user to enter a temperature, and we're going to store that in the variable temperature. The second, we are going to prompt to ask the user if it is summer. Is it summer? 0 equal no, 1 equal yes. And we're going to store that in the variable named appropriately summer. So now we have read there's a temperature. We have read whether it is summer or not. Let's attack the logic of our code. So we're going to use a selection statement. Here we go. There we go. Selection statement. My particular approach on this problem. First, I want to get rid of the fact, the question whether it is summer or not. So my condition will be summer, variable summer, equals 1. Yes, it means it is summer. No, it means it is not summer. If it is summer, then I can go back to my board. If it is summer, then this is my range of acceptable temperature. So I'm going to go back to Raptor, and you can solve this entire exercise without using without using composed Boolean expression with more than one term. I'm going to, however, illustrate the usage of multi-term Boolean expression in this particular solution. So if I know it is summer, I'm going to say condition if temperature is greater equal to 60 and temperature is lesser equal to 100. Well, if this is true, then squirrels are definitely playing. Okay, so I'm going to put an output statement here, and I'm going to display on the screen output text, squirrels are playing. And there we go. If this is false, what does it mean? And you see, this is where you are going to progressively realize that writing code requires the code reading skills and debugging skills that we mentioned earlier. If I want to complete this picture, if I want to complete this diagram, I have to constantly, execute this code in my head and figure out what each execution path leads to. If summer is equal to 1, it is summer. If temperature is in the right range, then the squirrels are playing. Else, it is summer, but they are not playing. So I'm going to go here, and I'm going to copy this statement, right-click, paste it here. And I'm going to change it. Squirrels are not playing. And this is what I have so far. Now, what about if it is not summer? I'm going to copy this whole conditional statement, come here, and I'm going to, I need to be on the line, I'm going to paste it. What do we see here? Little typo here. Let me try this again, paste. Okay. What do we see here? Well, we see that we have the same test. Is that okay? No. We need to go and edit this condition. If it is winter, then the valid range of temperature is not up to 100. It's simply up to 90. So, if it is summer, I check that the temperature is between 60 and 100. They are playing if it is. They are not playing if it is not. If it is not summer, I check the temperature between 60 and 90. If it is between 60 and 90, they are playing. If it is not between 60 and 90, they are not playing. And then I have the structure of my problem pretty much solved it. I double check here. Summer temperature acceptable 60 100, winter 60 90. Go back to Raptor, summer 60 100, winter 60 and 90. We have code that is functional. And I will let you test it again and develop your own test harness. Actually, you will see that this is going to be the object of some of our upcoming exercise for you to test this particular program. You are more than encouraged also, if your solution looks really close to mine, to explore what other solution you could have to this problem. There are many different ways you can arrange conditional statement, using only condition that have only one term, using condition with two terms, condition even with three terms. You can use serially arranged conditional statement. There are many different ways to solve this problem. So at this point, I would like you to take some time. And instead of rushing to terminate all the exercise, I want you to take the time to explore this exercise and come up with at least, I would say, 2 or 3 different ways to solve it. Okay? Alright, we are done with this exercise.